Hi, AP Calculus students. Welcome to our 4.4a examples video. This video is going to take a lot longer than the notes video because, let's see, we have 6 problems. It's important to try lots of examples. You are going to find in this section, again, in general, the idea is easy. It's in the algebra, and you have to be super careful. In fact, I'm going to be so super careful about it too that I may even check my answers as I go, because it's not the calculus, like if I've made a small mistake in my algebra. But I'm hoping to give you some hints as we go. We are going to be integrating, so we're going to remember that if we need some extra assistance, if a lower and upper limit hasn't been given to us, and we have to find it ourselves, that maybe an area picture would help us. If they're asking us for a net position, which would be a displacement, that we know we can just integrate the function. Sorry, my cat's trying to get into the curtains. Here you go. Here you go. Is that better? Okay. And trying to help my cat. She likes to be behind the curtains. Let's see if that helped her. Anyway, in that, so when you integrate a function, that is the net position or displacement. However, if they ask you for total distance, that something has traveled, that would be the absolute value of that function. That seems okay until you realize that that means any positive areas that you would see when you draw a picture of your integral are good, and any negative areas you have to make positive. And so we have to know which areas are positive and which are negative to help us. So let's take a look at number 8 here. Here we go. And on number 8, let's see, let's get a marker ready. It says, evaluate the definite integral of the algebraic function and use a graphing utility to verify your result. So we're just going to do this analytically. And when we are together in class, I will show how you do that on the calculator, how you do that integration. There we go. And in fact, I'm going to make myself a note. There we go. So they are asking us to integrate on number 8 from 2 to 5, negative 3b plus 4db. So here's the first step we do. The first step we do is actually just integrate, right? So here is a exponent of 1. I'm going to add 1 and divide by the new exponent, right? And so I get a negative 3 halves v squared plus 4v. Again, I don't need the plus c, because when I do my f of b minus f of a, I'll have a plus c minus c, and they will eliminate. Plus, this is a definite integral. There is no general form. Okay. So now I draw a long line, long thin line, and I'm going to evaluate this integral f of b, capital F of b minus capital F of a. So here we go. So I am going to, this is my f of b, and I always draw my arrows, okay? And I use parentheses a lot. So when I put a 5 in here, I have negative 3 halves times 25 plus 20. This is my f of b minus my f of a. I will put a 2 into the function. This is 2 squared is 4, right? And 4 over 2 is 2. 2 times the negative 3 is a negative 6 plus 8. Now notice, you can see why it's really important to always use parentheses around f of b and f of a, because they're being subtracted, and that subtraction needs to be distributed, okay? So what I have here is a negative 75 halves right here. And then let's take a look. I can combine my like terms here and here. So this is a 2, right? And now it's a minus 2, right? And it's 20 minus 2 is a positive 18, right? So when I add these two up, then this is a negative 75 halves. You could turn it into a decimal also. Plus that's 36 halves. And that gets you a negative 39 halves. Let's see, right? 5 carry the 1. I think so. So that area would be a negative 39 halves. Again, just to be safe, right? Because there's so many fractions and stuff. On number 8, yes, we're right. Now, what this means is if you went back to the original function, negative 3b plus 4, that is very easy for you to draw a picture of, right? So if you drew a picture of that line, negative 3b plus 4, and only made it occur between 2 and 5, you would see a picture of the area. The area would be a negative 39 halves, meaning it would be the net of the area would be under the x-axis. Okay, so notice very careful math. And truly, you know, in your book, honestly, the algebra does get a little sticky. Let's take a look at number 36. On number 36, let's see. They are asking for, oh, they actually give a picture. Determine the area of the given region. So they have y equals 1 over x squared. And they do give you a picture of the area from 1 to 2. There we go. And here's a 1, right? And it goes like this. So what's going on here is when it says determine the area, nowhere on number 8, they told you to integrate. Okay, here, nothing says integrate. They want you to know, and they'll do that on the AP exam, that when you're asked to find an area between a function and the x-axis, that you know that that is integration. Just like when they ask you to find the slope of a tangent line, you know that's a derivative. So this means they want me to integrate. Now, if it's okay with you, I'm going to write this as x to the negative 2, this function. They want me to integrate x to the negative 2 dx from a lower, they actually call it a lower limit, to a lower limit of 1 to an upper limit of 2. Okay, how do we do that? We first integrate. We add 1 to the exponent and divide by the new exponent. So I have negative 1 over x, because this is x to the negative 1. But when I have to do math, I'm better with my positive exponents from 1 to 2. Okay, the next thing we do is f of b, negative 1/2 minus f of a is a negative 1, right? This becomes a positive 1 plus a negative 1/2 is a 1/2. And certainly you can see that this kind of makes sense. First of all, this is a positive value. This is a positive area because it's above the x-axis. And let's take a look here. This kind of makes sense because if you look at this rectangle here, this is a 1 by 1, and that area would be 1/2. It would appear to be about 1/2 of the 1 by 1 area, right? So we can check to make sure that this makes sense. Okay, on number 28, let's see what they're asking for. Evaluate the definite integral, and it is a trigonometric function. And of course, that's why I have it. There we go. So what do? We first integrate. The integration of 2 is 2x plus the integration of cosine is sine of x, because when I take the derivative of sine of x, I do get cosine. I am going to evaluate that from a 0 to a pi. Let's do our f of b. F of b, this would be 2 pi plus sine of pi is 0. So here's my f of b minus my f of a. When I put a 0 in, to 2x into sine of x, I do get a 0 out. So my answer is an area of 2 pi. Just wanted to make sure we got a little trig in there. Number 42. I know this doesn't seem so bad, and hopefully it won't by the time we get to the end, but let's take a look at 42 and see what's going on. So on 42, it says find the area of the region bounded by the graphs of the equations. So here's what they have. Y equals 3 minus x times the square root of x, and they give y equals 0. They're asking you for the area. Okay. Now, here's the issue. First of all, the issue may just be the function, right? But we're going to have to work with that. That's our algebra. We're going to have to be good at that. Y equals 0 is the x-axis. So they are asking us to find the area between this function and the x-axis, which we know is an integration. The problem with that is they didn't give me an upper or a lower limit. So I am going to put into my calculator, because this is our first time doing it. We wouldn't use a calculator to do this problem. Certainly it wouldn't be that way on the AP exam. But I just want you to see, when I put this problem into the calculator, and I'm just going to zoom in a little bit, that the reason why they didn't give you an upper and a lower limit for the x so that you can integrate easily is because, let's see if you can see this. This is a function. You're welcome to put it in your calculator. That this area, this function bounds itself to the y-axis, right? It creates its own area. And so what we have to do is find the x's at the left and on the right of the function that bound the area to the x-axis. Now, when I take a look, that seems to be a 0 and a 3, but we're not supposed to use a calculator. So here's what's going on. What do we do then? Let me just draw the little picture that I see here. So this seems to be a 0 and a 3. So it creates its own area, and we have to find the x's that begin and end that area. Okay, so because they wanted area, we do know that we are integrating. Now, first of all, if it's okay with you, I'm going to call this square root of x, x to the 1/2. Okay. Now, what I need is the lower limit and the upper limit. Well, those are the x-intercepts, right? That is where the function equals 0. So I'm going to set the function equal to 0. Now, you may feel like, I can't do that. Yes, you can. You know that 0 times anything is 0, right? So I need 3 minus x to be 0, right? That would be x equals 3, or I need the square root of x to be 0, right? And so it's just that we set the factors equal to 0. Okay, so here's my lower and my upper limit. And they asked me for area, so I know I'm integrating. Well, notice this is a product. I don't know how to integrate a product, right? So I am actually going to distribute this x to the 1/2. That's 3 times x to the 1/2 minus, this is x to the first. So when bases are the same, they're being multiplied. This is x to the 3/2. Okay, let's go ahead and integrate. I am going to add 1 to the exponent and divide by the new exponent. I am going to add 1 to the exponent and divide by the new exponent. Okay, I think I need to clean this up a little bit before I can evaluate it. So let's take a look. Oh, don't need an integral sign. We integrated. Okay, so rather than divide by 3/2, I'll multiply by 2/3. 2/3 times 3 is 2. And this is x to the 3/2. Okay, minus, rather than dividing by 5/2, I'll multiply by 2/5. and that's x to the 5 halves. And I am going to evaluate that from 0 to 3. Okay, so I'm going to erase here, give myself some room. Okay, f of b minus f of a. So I'm going to put a 3 in for the x here and here. This is where, right, our first tricky part was finding the lower and upper limit ourselves. Now it's the math, okay? So if you're like, wow, 3 to the 3 halves, 3 to the 5 halves, and that's going to throw you off, do it in very small steps. So here we go, f of b. I'm going to put the 3 in. 2 times 3 to the 3 halves. I'm a little scared of 3 to the 3 halves. So I'm just gonna put it in. I'm just gonna write it, right? Worry about it later, right? Mine is 2/5, and this is 3 to the 5 halves. Okay, there's my f of b, right? Minus. Now, luckily, when I do my f of a, when I put a 0 into each, I do get 0. So for all the weirdness I have going on here, thank goodness, the end was a little easier. Your answer is not going to look like this in the book. Okay, so here's what I would do. Stick with me on this. Take a look here. Here's my 2. Now, if you notice, this is 3 to the 3 halves. That's an improper fraction. I am going to write my 3 to the 3 halves. I'm going to break it up into, there we go. Let's take a look. Whoopsie daisy doodle. Okay, 2, right? And if you notice, this is when bases are being multiplied, you add the exponents. Notice I still have the 3 halves. But I like this here because this is really 3 to the 1st, right? Okay, minus 2/5 times 3. I'm going to break this 3 up. I'm going to call that 3 to the 4 halves times 3 to the 1 half. What I wanted to do was basically know how many whole 3s are in 3 to the 3 halves and 3 to the 5 halves. So if you notice, what I have is the same as above. Okay, now this is 2 times 3 is 6. This is a square root of 3 minus, you don't have to make it radical, I just am. Notice that this is 3 squared, this is 9, this is 18/5 right here. And that's the square root of 3. Notice I actually have like terms, right? Only I don't have a common denominator. So let's turn 6 into 30/5. That's still a 6. Square root of 3 minus 18/5 square root of 3. And you get 12/5 square root of 3, which is in fact the correct answer. But again, the integration was easy, right? It was the algebra. Okay, so let's do number 25. Okay, let's see what the issue is with 25. Why are we going back to 25? We are going back to 25. Oh, yes. Okay. Again, class, on the AP exam, absolute value functions are the norm, not the exception. So on 25, they are asking you to integrate from 0 to 4 the absolute value of x squared minus 9. Okay, dx. Okay. Now, what this means is they are asking us to find the area between 0 and 4, between x squared minus 9. We know what that looks like, and the x-axis. But they want the absolute value of that. Now, there's 2 ways of looking at that. Notice before with absolute value with derivatives, we were able to always use our knowledge of transformations, okay? So there's 2 ways of looking at this, okay? I think for an area to help myself out. Okay, here we go. I know how to draw x squared minus just on its own, not concerned about the absolute value signs yet. Okay, so down here at -9, and it hits here at 3, and it hits here at -3, right? So this is a picture of x squared minus 9. Okay, now, but it's going from 0 to 4. Right, so now I'm going to draw a picture of the area that they want for me because I know that's what an interval is. Okay. So I'm going to close off that area. So they want this area added to that area where we consider both of these areas positive. Okay, what this means for me is I need to break up the integral. I know if I integrate x squared minus 9 from 0 to 3, that it's a negative area. And then I have to take the opposite sign of that and make it positive because it's the absolute value. The area of x squared minus 9 from 0 to 4, 3 to 4 is positive and it's fine like it is, right? Another way you could do this is you may say, well, Ms. Culver, what if I just draw the whole function, not just x squared minus 9, but the absolute value of x squared minus 9. If you know what that looks like, you don't have a calculator in your hand, right? But how would you do that? How would you do that? Let's take a look. So here's -9, here's 3, here's -3, right? So I just drew, once again, x squared minus 9. Well, what does the absolute value do? It takes any negative values and makes them positive, right? So all these negative values become positive, right? So this is an actual picture of the absolute value of x squared minus 9. And then again, I'm trying to find this area in this area. Okay, let's go with the first picture that we drew though. Because we have two different areas and we have to take the opposite sign of this one and keep this one positive, our algebra is going to be sticky and we have to be very careful. Again, I even make mistakes myself because there's so much going on. So here's what I'm going to do. I am first going to integrate from 0 to 3 x squared minus 9. Not with the absolute value sign in it. I can see that this is negative, and so I take the negative of that integral, right? And then it will make it positive. Plus, then I'm going to have to integrate from 3 to 4 of x squared minus 9. But because I can see that area is positive, I can leave it as it is. Let's go ahead and integrate. Okay, this will be add 1 to the exponent, divide by the new exponent. X cubed over 3 minus 9x. Okay, now, just checking to make sure I did that right. Again, there is a negative out front. Now, when I do my f of b minus my f of a, that's going to get really confusing that there's a negative out here. So I always do distribute that negative so it's right on the function. Okay? So my first term will be negative and my second term will be positive. Otherwise, there's just too many bits and pieces that will allow me to make mistakes. Okay, there's my first function. I'm going to evaluate that from 0 to 3 plus. Now, when I have two different integrals, I tend to put a plus sign in between. Why? And circle it is what I was going to say. Because I have a plus sign here and I might get confused as to where I actually am. So I do these little things to help myself. Let's integrate here. That would be x cubed over 3 minus 9x. And I will be evaluating that from 3 to 4. Okay, you can see I'm going to have an f of b minus f of a here. I'm going to have an f of b minus f of a here. Okay, I'm going to erase my pictures, give myself some room. Okay, I think I need a new marker. because it's just not showing up too dark. Here we go. F of B here and here. When I put in a 3 here, that is a negative 27 over 3. That is a negative 9. Okay. When I put in a 3 here, that is plus 27. Okay. Minus. That was my F of B of the first interval. Minus. When I put a 0 in for my F of A into both expressions, I do get a 0 out. So that's kind of nice. Okay, there's my F of B minus my F of A for my first interval. Plus, with a circle on it, indicates to me I've moved to the next interval. F of B, that would be 64 thirds F of B minus 36 minus, now I'm going to do my F of A. 27 divided by 3 is 9 and minus 27. Okay, let's take a look here. We have an 18 plus 64 thirds. I don't feel like messing with that right now. Let's take a look. Minus 36. 9 minus 27 is a negative 18, and now it's a positive 18. So take a look here. I have 18 plus 18 is 36 minus 36, and I get 64 thirds. Look at that. I didn't even have to deal with the fraction. Let me take a check again. Even though I taught this for many years, you can see there's so many opportunities for little things to happen, even to teachers. We have the right answer. Let's do the last, number 97. Now, I assigned to you number 98. So please pay close attention. This very much on 97 is just like a problem you would see on the AP exam, and it will help you with 98, of course. So in bold on 97, here's what it says. A velocity function in feet per second. Okay, so we are going to remember this is a velocity function. So when you put a time in for t, it does give you the rate at which a particle, they love particles, is moving along a straight line. The time is from 0 to 3. Okay, makes sense that time is only positive. Here's what they want. They want A, find the displacement. Displacement. So you need to know what displacement is. Displacement, right, is when I displace myself. It is my net position. Now, we automatically know we're going to integrate, because if we have a velocity, we know if we integrate, we get a position. So we already know what our math is going to be, right? And they also want from us B, the total distance that the particle traveled. Okay, I am immediately going to put absolute value signs because I know that that's what that means. Again, I know I'm going to integrate, because if I integrate a velocity, I get a distance. Okay. Again, if I start at school and walk to the lake and back, my net position is 0. However, I absolutely have walked a total distance, right? So what do we do here? Displacement, net position is easy. We just integrate. We don't worry about anything. We just integrate from a time of 0 to a time of 3 of 5t minus 7. So let's integrate. There we go. 5 halves t squared minus 7t. From 0 to 3, we're going to do our F of B. F of B would be, let's see, that's 9 times 45 halves minus 21. And minus our F of A. When we put a 0 in, we get a 0 out. So here is my F of B minus my F of A. 21, I'm going to write that as 42 halves. And I get 3 halves. And so that the net displacement of that particle is 3 halves. And it was in feet per second, so it's in feet. What does the positive 3 halves mean? It means that it was displaced from its starting point at a time of 3. It was 3.5 feet to the right. If it was negative, that would be to the left. Okay, so total distance means that I have to integrate from 0 to 3 the absolute value of 5t minus 7 dt. Again, anytime you see the word total, you have to be better than the other students in the United States and around the world who forget that total means absolute value. Okay, so what this means for me is there's 2 ways. I could draw this absolute value function right here, but you would have to be super careful, okay? This absolute value function, to split it into its transformations, you would have to factor out a 5. And now you can see that it's the absolute value function moved to the right 7 halves, and it has its slope is 5 times steeper. Like you could draw yourself a picture of it and then find the area from 0 to 3. That might not be something that you handle super well. So I'm really good at drawing the area of, drawing a line, 5t minus 7. So I'm going to do that, okay? And then just make my negative areas positive, keep my positive areas positive. Let's take a look. So this is -7, and then a slope of 5, right? So very steep. So what I need to know is, let's take a look. I need some information here. Where is it hitting, right, the x-axis? Well, let's see. That would be where the function equals 0, right? So I'm going to add a 7 and divide by 5, right? So this is at 7/5 right here. Obviously, this is at 0. It has to end at 3. Let's put in a 3 right here. When we put in a 3 right here, I get 15, I get 8. So this is up at 8. So I need to find this area and this area. Now, this is kind of interesting because these are triangles, right? So I could just find the area of those triangles and make them both positive, right? So there's 2 ways I can handle this. First of all, I could break up my integration into this area and this area. Okay, notice that my first integration would be from 0 to 7/5 of the function 5t minus 7. Because this area is negative and I'm doing the absolute value, I would put a negative in front. Okay, plus my second integral would be from 7/5 to 3 of 5t minus 7. I would integrate here and distribute the negative, evaluate f of b minus f of a. Here, I would integrate and evaluate from 7/5 to 3. Okay, let me offer you, though, another idea here. I think I'd be better with these areas. Let's look at this first area here. I know how to find the area of this triangle. It's 1/2 the base times the height, right? So let's look at this right here, doing area. I have 1/2. My base is 7/5, and my height is a -7. However, I'm going to make that positive because this area needs to be positive. I'm doing the absolute value. Plus, let's find this area. That's 1/2. Okay, 7/5. That's 1 2/5 to 3. I should have figured this out, right? So that would be 2. That would be 1 3/5. Would be this base right here. right? So if I add 1 3/5, that's 8/5. Yes, so 7/5 plus 8/5 is 15/5, which is 3. So that would be 8/5 is the base here times the height. Okay, so let's look at this again. I know an integral means area, and I'm like, I'm good with triangles. I think I'll just use the areas. Okay, this area, 1/2 the base times the height, and I made sure to keep it positive. This triangle here is 1/2. This base, I determined if I added 8/5, I would get to 3, and the height was 8. So let's take a look. We have 49/10 plus this is 64/10, and that total area is 3, carry the 113/10. And it is, that is correct. And of course it came out positive. That's all that we were allowed. So anyway, it's a lot, isn't it? Do each problem very carefully in small pieces to help yourself watch your negatives. Mark things for yourself, like when you have 2 integrals, right? And just very carefully. It can get frustrating when you think you've done everything right and you get to the back of the book and you're like, oh, I'm not right. Usually it's a little mistake that you made. It happens to teachers too. Have a good day.